Hello everyone, the title of my paper is From Cities to District, Combined Analysis on Density Variation of Chinese Cities in Different Climatic Zones. After the developed countries, today the cities of the developing world are outdoing their teachers with more pollution and social problems. In China, compact city-related developments need to be embedded and properly guided to identify best practice for Asian cities. This paper forms part of the data analysis in the author's higher research degree thesis. The position of this paper in the whole project is in one part of the Objective C exploratory analysis of the HSEFA indicators and urban strategies at both urban and district level. From the literature, it is found that there are several steps in the knowledge about the relationships between the urban climate and built environment sustainability in China. The traditional reductionist methods of analysis, which break down and isolate the component parts, will bring the risk of fragmented decision-making with potential unforeseen consequences. So systemic, holistic, goal-directed, and hierarchical assessment of sustainability is needed. The focused city in existing quantitative and qualitative analysis have primarily confined. The last gap is that the influencing climatic indicators that would affect urban form are lacking in the literatures. Synthesis from above, the aim for this paper is to propose recommendations on best practice in urban form in different climatic zones of China and find out the influencing indicators of urban climate, which is one of the 16 modalities in the holistic sustainability evaluation framework for Asia-Pacific regions. In analysis, both statistical and qualitative analysis will be used. According to the sustainability evaluation framework in this research, the macro-scale strategies correspond to the quantitative indicators. For the statistical analysis, PASW statistic will be used. The macro-scale strategies correspond to the qualitative criteria. The first step in this paper is to identify the climatic indicators from the literature review and collect the density data of selected cities. The second step is to conduct exploratory data and analysis using the key means cluster analysis method and ANOVA analysis method. Multivariate analysis and clustering will be used for the factor analysis. It will be evaluated the significance of climatic indicators and make quantifiable comparison between 85 cities. The estimated details of analysis outputs are the summary of the influencing urban indicators presented in a correlation table and a scatter graph. Recommendations on design strategies and design tools for sustainable development are presented in cross tables. Adapted from Newman and Wenli, this picture shows that there is an intricate relationship between urban density and energy consumption. North American cities are among the most energy-intensive, while Asian cities are more energy-friendly. Based on their theory, this plot chart shows that urban density and energy use in the second-tier Chinese cities. There are similar groups showing that some cities, which are mainly in the middle and western part of China, have comparably lower density and higher energy consumption. The intermediate group of cities mainly located in middle China, and the largest group shows where the higher density, lower energy consumption cities located. 85 cities, which will cover middle and east of China, are selected for the first step analysis. Convenient sampling method is used during the preliminary research. The 5 Chinese cities, each located in 5 zones, will be examined for this study in the second part of research. They are chosen for similar city scale and arithmetical latitude. In order to analyze the density differentiation in different climatic zones, the climate indicators are identified from a climate consultant. According to it, the 6 most important climatic indicators are identified as main indexes, as well as the 7 subsidiary indexes. The framework developed in this research comprises hierarchical modalities, where the built environment and the natural environment are 2 of the 4 main modalities of sustainability. Correlation analysis of 85 cities reveals that the natural ventilation cooling is statistically significant. High summer mass, conventional heating, and conventional air conditioning are more related to urban population density than other indicators, but the correlations are not statistically significant. The graph below shows the scatter plots in the 4 analyses. Overlay scatter plot shows that the combination of 2 or more climatic indicators would affect urban density much more significantly. For example, The linear regression analysis reveals that sun shading and internal heat gain together affects the density to be more statistically significant. For further investigation, cluster analysis is used to find out whether two or more climatic factors would affect urban density. With the purpose that the cluster may be in accordance to the existing climatic zoning, the number of targeted clusters is set to be 4. The result represents an equal distribution with similar number of cases in each cluster. The CI plot in the combinational indicators analysis shows that the population density varies when sun shading index increases and the humidification index decreases. But the ANOVA analysis shows that there is no statistically significant differences between the 4 zones. The 4 clusters of humidification comfort zone include the equal cities in each cluster, but there is also no statistically significant difference between the cities in different humidification comfort clusters. This is similar to the conventional conditioning and humidification clustering. When there are 2 clusters, there is statistical significance between the climate clusters. But when there are 4 clusters, there is no statistically significant difference between the densities in climatic clusters. Within these comparably energy-friendly cities, considering the number, representativeness, and order to cover more variations, 5 cities are selected as the research cases. I collected some data on the 5 cities and built up density models from north to south. The left map shows the constructed urban area, municipality area, and metropolitan area. A second and third maps shows the 2D and 3D density distribution of the key cities. They are Harbin, Tianjin, Wuhan, Chongqing, and Shenzhen. Considering the multiplicity of influencing elements, it will be convenient to integrate a district of similar characters, so the district under the administration of boroughs are more appropriate units for analysis. It provides a subdivision of the whole city area into different districts according to their different terrain, the orientation of streets, street grid, transport facility, and history. A set of quantitative indicators to characterize urban forms at a metropolitan level are developed to distinguish the compactness from sprawl. Indicators of the above cities are calculated in order to better understand the dimensions of density distribution. But there is still no substantial evidence from the calculations. So an in-depth investigation into the variation among the districts with similar cultural and physical environments is strongly needed. The district need to be classified into central urban area, outer urban area, and peripheral urban area according to their proximity to the city center. The chart below provides the effect of the centrality on the urban density. The chart shows that the number of cities which have districts that meets the 2 variables. The comparison of the chart shows that the urban central area, outer central area, and periphery available district cluster at different density ranges. The outcomes is displayed in the 3-dimensional charts. Seen from this figure, the district with radial district grid are mostly consolidated, following the 4th south-oriented district. All of these are in accordance with the trend that the district depopulation densities are generally high in this district with significant conventional conditioning, humidification, wind protection, direct evaporation cooling, high thermal mass, and passive solar direction gain low mass, where the district with the significant conventional air conditioning, internal heat gain, sun shading, comfort, natural ventilation cooling, and passive solar direction gain high thermal mass indexes naturally come into the relatively average low-density district. In the periphery of the urban areas, the trend with the climatic variation still exists, but it is much weaker than in the conventional conditioning and humidification climatic regions. In the first part of the research, the statistical analysis of 85 cities shows that natural ventilation cooling is closely related to urban population density. High thermal mass, conventional heating, and conventional air conditioning are not statistically significantly related. 2 or more climatic factors would affect urban density much more significantly. For example, sun shading, humidification, comfort, humidification, sun shading, internal heat gain, conventional conditioning, humidification, etc. At the macro level, an in-depth investigation on over 400 sub-districts presents the case studies of 5 typical Chinese cities in each climatic zones. It verifies the 13 climatic indicators in the district level and extends the vision into the specific parameters of urban form strategies. Recommendations from the 5 cities are shown in the cross table for references. Thank you.